The idea that properties of objects such as volume, number, mass remain the same despite changes in the forms or the shape or the identity of objects. They don't conserve these aspects. So let me put this on. And here it is.
Do you think that they have the same amount of juice? You think they have the same? Okay. Now we're going to pour this juice into this glass. Now, do you think that this glass has more juice, this glass has more juice, or do you think that they have the same amount?
That one has more.
This one has more, and why do you think that this one has more?
Because it's taller.
So first we're going to look at these two cups right here. Do you think there's the same amount of juice in this glass as there is in that glass?
They're even.
They're even? Okay. So we're going to take the juice from this glass and pour it into this one right here.
Okay.
Okay, so now we're going to look at this glass and that one. So do you think that there's more juice in this glass, more juice in this glass, or do you think that they have the same amount?
Same amount.
Okay, why do you think that they have the same amount?
Just because this is skinny doesn't mean it's not the same amount. It has the same amount of juice in it, but this one is just wider and this one's skinnier, but they have the same amount of juice in it.
Okay, you ready?
Yeah.
Okay. Does this row have more quarters? Does this row have more quarters, or do they have the same?
1, 2, 3. Wait. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They're both the same.
They're the same?
5, 5.
Okay. Okay. Does this row have more quarters? Does this row have more, or do they have the same?
This one has more.
That one has more quarters?
Yeah.
Why does this row have more quarters?
Because it's more far away.
It's more far away?
Yeah, it's more far away than that. Looks like bigger.
All right, we're going to play a game with the graham crackers, and we're going to share them between me and you, okay? Okay. Do you think that we shared those fairly?
No.
No, why not?
You have those and I have this one.
Well, what if we try this? Okay, can I put this down right there?
Okay.
Now is it fair?
Yeah.
Yeah, why is it fair now?
Because we both have two.
How many people have done that with their little brothers and sisters? When it comes to pizza, here, I'll just take your slice. Now you have 3 pieces and I have equal. They'll remember all this later, by the way, what you've done to your younger siblings. It'll come back to haunt you when you're an adult and they figure out when you did that. So concrete operational, now they can actually solve conservation problems. So you saw the girl, and she can even explain it quite well as why clearly these two, vessels have the same amount of water. Just because one is tall and skinny doesn't mean that there's any more. She's able to conserve the idea here of volume. But there doesn't seem to be, like Piaget mentioned, this is one of the problems with Piagetian theory, is that if you're talking about a stage model of development, then during the concrete operational stage, you should be able to solve all of these conservation tasks, at the same time. And it doesn't seem to be the case. In fact, some of these may not be able to be solved until later. So for instance, number is solved first. So they're able to conserve number before they can actually solve for length and weight. And length and weight are solved last. And it may be because number, you can actually count them, which I still don't understand that little girl. This is how pre-operational she was, is that she can count, yet didn't even think of counting because, the dimension of here, in that case, length of the coin, why even bother counting? Clearly there's more here, right? So, when we take pre-operational, they're really pre-operational. But during this period of concrete, when they can actually solve these tasks, it seems that they're still not all solved at the same time. Numbers first, length and weight are solved last. The other thing that happens here is child can also start to solve mental problems, such as class inclusion and seriation. Class inclusion, I'll just give you an example here. What class? Something that belongs to a higher class, right? So if you say to a child, suppose we have 20 wooden beads. So you got 20 wooden beads. 17 of them are red, and 3 of them are white, but they're all made of wood. So you got 20 wooden beads, 17 are red, 3 are white. Are there more red beads or more wooden beads? Right? And of course, the child will say that there are more red beads. They can't get the idea that there can never be more red beads than wooden beads. They're all wooden. But because there's 17 red and 3 white, there are more red beads than wooden beads, right? So they don't get the idea of this class inclusion, belonging to a subordinate, belonging to a higher ordinate class. So again, if you ask a child, what would make the larger necklace, the wooden beads or the red beads? They would say, the red beads, yeah, clearly. You can do this again with other things. You can do it with animals and cats and with apples and fruit, and they will say that there are more cats, than animals, or there are more apples than fruit. And the child who has, reached this level, going up into the, who has achieved the concrete, or in this case, class inclusion, will understand that there can't possibly be more red beads than wooden beads. There can't possibly be more cats than animals, or there can't possibly be more apples and fruit. So they get that idea of subordinate classes within a category of different dimensions. So class inclusion is one of the milestones of concrete operational. And seriation. Seriation is just basically putting things in order of sequence. So you were to give a child in this period, or before they actually achieve this milestone, if you give them, let's say, sticks of different lengths, or something at blocks, let's say, of different sizes, and ask them to put them in order of size, they can't do it. They'll take a couple of them and put them together in little groups, but they're unable to get the idea of sequence. So seriation means putting them in a serial order, right? They wouldn't be able to do that. So again, this happens during the concrete operational period. Transitivity is the last one related to this idea. And I put this down here just to kind of give you a better example, because it's kind of hard to explain it verbally. So transitivity is just to be able to combine relations and deduce conclusions. So in other words, if A is greater than B and B is greater than C, then A has to be greater than C, right? So again, kind of going from the if and then, almost like deductive reasoning. So again, it's not deductive. I shouldn't say it's deductive, because it still has to be in the here and now. They have to be able to see it. They can't deduce this mentally, which is why it's called concrete operational. It still has to be something you can see and deal with in the real world. They can't deal with things abstractly. So transitivity is the last concrete mental task that they have to achieve during this period. Does that all make sense? It's all good? Okay. The other thing that they will do during this period is we start to have decentration. Now, I'd mentioned what centration is and conservation. What is decentration? That's going to occur during this period. What is it? Decentration. I told you what centration is. So you're centering on one aspect of a stimulus and not being able to conserve the other parts, right? So you're only centered on one dimension. It could be only volume, or it could be only, number, and you don't get that the change in the other stays the same. So what's decentration? This is going to be the milestone during this period. Yeah. Yeah, being able to decentrate, to move or refocus, to take your mind off of only one dimension and be able to process all of them, in the ability to now see that nothing changes despite a change in one dimension, right? So you're becoming decentrated. That comes with, again, reversibility. So if I take a glass and they're equal and I pour it into a larger one, you can solve that problem not only by decentration, but also by reversing the process. Well, what if I were to take the water and put it back in the original glass? I would still have the same amount, right? So again, the whole idea of reversibility, undoing operations, right? This happens during this task where they're now able to understand reversibility, which is why the period before this is called pre-operational. You can't do these kinds of operations on objects mentally. So this will occur by the end of this period, is the ability to decentrate and again use reversibility to achieve the ultimate task here of conservation, right? They're also now able to take perspective, develop perspective taking, so understanding what somebody else is looking at, so the three-mountain task. They will start to understand that just because I'm sitting here and I'm seeing one thing, if you're sitting over there, you would see a different thing. So again, perspective taking. One of the things that children have a problem with, again, with symbolic ability, is what we call dual representation. And in dual representation, they're unable to mentally represent two objects as being the same. So for instance, in a scale model, what they've often done to demonstrate this experimentally is, let's say you have, they'll often use little toys. So they'll have, let's say, Snoopy. And they'll have a Snoopy doll, and they'll also have maybe a drink, a can of Coke or something. And they'll have Snoopy and, the can of Coke, and they'll hide the can of Coke somewhere, I don't know, in a closet or behind a pillow on a couch or, on top of the TV behind a picture. And the child sees you place his object there. And then they have Snoopy, go and look for it. Of course, the child is able to go and look for the can of Coke. They see where you hid it. They go and they find it in the room. But then if you have a scaled down version of a room, let's say a little model, like a dollhouse, and the experimenters actually replicate the room that the child is in, looking for the can of Coke in the first part of this, it's identical. So it's a scaled down model. If you hide the actual can of Coke in the main room and then ask the child to go to the scale model to find the can of Coke, they can't do it. So they can't have a dual representation of, in this case, a room. They can't represent two things equally. So if you have a model or a scaled down version of something, they can't have two representations of it. To them, it's two different things. But in the classic experiment, what the researchers did was they told the child, we've shrunken the room. The room that we're in, we've just shrunken it. So I want you to find the can of Coke. They were able to do it then. When you allow them to see that the two things stand for the same idea, they were able to do it. So in one of the classic videos called the shopping cart study, or the, where is it? The scale error, here it is. I'll show you what these children do.
At Judy DeLoach's lab at the University of Virginia, while studying children's understanding of scale, researchers discovered a very surprising phenomenon involving self-awareness, a crucial step toward becoming a social being.
All right.
2.5-year-old Madeline is invited to play in a room full of large toys. At this age, she already has a sense of herself and would have passed the shopping cart test with flying colors. She's given hands-on experience with each toy in the room. Researchers wanted to know what the baby human would do if they replaced these life-size toys with perfect miniature replicas. How would they physically relate to them?
I'll go for it.
Madeline notices that there is something different about the room now.
Why don't you pretend like it's the big one and you can get in and take it for a ride?
But that doesn't stop her from treating the toys as if nothing had changed. Ignoring the size of the car, she proceeds to try and get into it.
That's a good idea. You should push it in as far as it goes.
Many other 2.5-year-old children tested responded in the same way as Madeline did. They did not modify their behavior with the toys, even though they could see that they were smaller. So the researchers wondered, why would the baby human, who by the age of 2.5 has a sense of themselves and their own bodies, ever relate to the miniatures as if they were still full-size toys? It seems that the baby human wants to play with the toys so badly it can cause them to momentarily disregard the difference between the size of the toy and the size of their own body.
Where is it?
It's right here.
Judy Deloche has concluded that at this age, the baby human's sense of scale is so fragile that their emotions can occasionally override their perception of themselves. But their perception of their physical self includes one other major aspect of becoming a social being.
Twinkle, twinkle, little star,
And that is gender.
what you are.
Bravo.
Look, Nancy, look at the shopping cart.
At Chris Moore's lab at Dalhousie University, researchers developed the shopping cart study to examine this question.
Look, so you can roll it up like that. See that? And you can push it.
15-month Ainsley is introduced to the shopping cart.
I'm going to get you to push it.
After a brief demonstration, researchers wanted to see if Ainsley will figure out how to get the cart to her mother.
Show Mommy. Bring the cart over here. You want to bring me the cart? Let's push it over. Goodness.
Ainsley pushes and pushes.
Come here. Push it over.
The cart does not get any closer to her mother.
Push it. Push it. Let me see. Over here.
Researchers believe that in order for the baby human to solve this problem, they have to have a sense of self. At 15 months, Ainsley has no idea that it's her body that is preventing the cart from moving.
Yeah, can you show me?
Is that a special cart? That's a very special cart.
Next comes 14-month Oscar.
Nice. Come show me. Come show me.
He too can't figure out why the cart won't move.
What's the cart?
Out of frustration, he tries to climb into the cart. 16-month Maria gets a bit closer to solving the mystery. She knows it has something to do with the mat, but doesn't make the further connection to herself and thinks it's the mat's fault.
Push it to Mama. You push it to Mama.
18-month Jonathan pushes once and steps off the mat. He has quickly figured out that he's the one who is the obstacle to moving the cart, which suggests that he is aware of himself and his body.
You bring it over to Mommy. Can you bring Mommy the cart? Can you bring it over to Mommy?
Abigail is also 18 months.
Bring Mommy the cart. Yeah. Oh, you're such a good girl. You push it over to your mom. Bring Mommy the cart.
She takes a walk to the front of the cart to analyze the problem.
Her.
Bring Mommy the
It
cart.
takes her no time to understand that if she is standing on the mat, there is no way the cart can move.
Abby, bring on the cart.
Her solution is to roll up the mat.
Oh my goodness.
From this, researchers have concluded that baby humans become aware of themselves only after 18 months of life.
Look at the
Girl,
girl.
Mommy.
Better way to show you what I mean by dual representation here than that. So the idea that you can't represent a scale as, you know, a bigger thing, because to them it's two different objects, so they don't see the relation. And then after a while, of course, they, you know, during this period, they will start to understand that things can take on different representations or symbolism. The actual shopping cart study, again, in the scale model, these are all showing that it takes time to develop a sense of the self, a mental representation of the sense of self as separate from objects in the environment. So you have to then disengage, and once you can do that, and it appears to be about 18 months old, is when babies do have a sense of identity. There's another classic example called the red dot study, or the mirror study. And again, I might show this to you next class, where the child is not aware of the self as being distinct, as you saw in this video. And what they do is they put a red dot on the child's forehead, and they show the child a reflection in the mirror. And children who don't understand that they are unique, separate from other people, don't really notice that it's them, and they're looking for the other child behind the mirror, going, hello, hello, right? Children who have a sense of self start pointing to the dot and saying, what's this? My head. And again, getting an indication that they're aware that it's them in the mirror and not another child hiding behind the mirror. So that is a really old study, one of the first ones, and it's on a VHS. I have it at home, but I didn't bring it in, but I can show that to you next. It's only a couple of minutes, but it's really cute.